This, for the most part, is review. Okay? But I did some thinking because we've factored things in the past, and we're going to start by factoring. Our purpose for this unit overall, you know those long polynomials we were talking about with the end behavior? They could be odd, they could be even. They got like up and up, down, down, up and down, this way, that way. Those long polynomials, right? We're going to find where it crosses the x-axis. Okay? We're going to find like when the polynomial equals 0. Those are important parts of polynomials, zeros. So like, you know, this x squared graph, it looks like that. The zeros are very important. Why are zeros important? What's that? What's that? No, don't draw that. I'm asking you a question. Why are zeros important? Separates important values on our function. Yes, separates positives and negatives. Zeros are always separating positive values from negative values. If you know all your zeros, all you need to do is actually test 1 point to know the signs of all of your values in between your zeros or outside your zeros. When we know things are positive and negative, there's a lot of applications for that. It's also like, instead of solving an equation equal to another equation, having one equation equal to 0 is actually going to be like easier to solve. We'll see that. So that's what we're going to do. But to do that, we need to know how to factor. Okay? And a lot of this is review, but there's going to be some new stuff, some new factoring techniques that we're going to learn. Okay? Now, we're gonna go through this very systematically. Also, I'm going to teach you a new way to factor that I think you'll like. Okay? Because you didn't like factoring certain things back when we factored. What do we factor? Do you guys remember what we factored? The Q word. The quants? No. What? No. What starts with a Q?
Quadratic.
We factored quadratics. We factored x squared equations. Now, we know polynomials are not just x squareds. It could be x cubed, x to the fourth, x to the fifth, x to the sixth. Okay, we're going to factor those. But we factored x squareds. Some of us, we did a decent job. Some of us just gave up when they got complicated. I'm going to try to give you an easier way to factor. Okay, but here is going to be a formulaic process when I ask you to factor something. Okay, ready? Step 1. And we're going to go through every single example. Okay, one step at a time. Step 1. Factor out a greatest common factor. You can write that down, Mr. Clark, okay? Stop doodling on your notes. You're disrespecting my notes. Is that like a garbage bag? What is that anyways? SpongeBob. Goodness gracious. Mr. Clark, you're front and center from now on. That's your new seat. Yeah, go. Yeah, top middle. I formation, lead blocker. Let's go. Thank you. Okay, what do I mean by factor out the greatest common factor? You're next, Mr. Reyes. You did that on purpose, though. I know you. Did what? Okay. Yeah, I'm going to. Now you just distracted me. What can I pull out of every single term? I look at 3x squared and 21x. Do they have things that they share? X, okay, good. Anything else? 3x, okay. I look at every single one of these examples and I say, can I pull one thing out of everything? This is always the step 1. Can we factor out a greatest common factor? Okay, now, if I pull out a 3x, you can think of it as dividing. Or you could kind of backwards distribute and ask yourself, what times 3x give you 3x squared? Mr. Black, what do you get? X. 3x times x is 3x squared. Or I can think 3x squared divided by 3x is x. Ms. Brown, if I pull 3x out of 21x, what do you think I have? Okay, well, you can either think 3x times something is 21x, or I could think what is 21x divided by 3x? 7? Yeah, plus 7. Okay, good. All right, let's look at the second one. Can I pull out something from all three of those things? 1. I would not call that a greatest common factor. We will always be able to pull out 1. If that's it, then I'm done. Now, we might be thinking, hey, maybe I could pull something out of these 2, but actually, when we're factoring, we're going to either pull something out of all of them, or we're just going to leave them. Okay, please look at the third one. Can you pull something out of that? 2 and an A. Everybody factor out a 2A. Now, when we factor out, it's like dividing. You could either think about dividing, or you could think, okay, 2A times what gives me 12A cubed? 6A cubed? 6A squared. What about minus 22A squared? Is it 11A? Okay, everybody finish it off. See if we can do it. Very good. Minus 11A. Miss Barry, what about when we pull out 2A from 8A? Now you got a 4. There you go. Good start. And actually, what this is just a start. So we're going to continue in the future. But we're going to just go through all these. Can I pull something out of these 3? Nope. Can I pull something out of 12, 17, and 7? 2 of them have x's, 1 of them doesn't. Nope. Skip it. 8x squared, 2x, and 15. I want to pull out 2, but I can't. Skip it. 6x to the 5th and 3x to the 4th. Got a 3? 3x to the 4th. Very good, Ms. Birch. Okay, factor out the 3, x to the 4th. All right, so Mr. Garcia, what'd you get for 3x to the 4th pulled out of 6x to the 5th?
2x minus x.
Is it 2x minus x? If I have x times 3x to the 4th, that'd be 3x to the 5th. 1. Okay? Next one. Can I pull out a greatest common factor there?
Where did you get the 1 from?
Where did I get the 1 from? This is a great question. So, it's like I pull 3x to the 4th out of 3x to the 4th. There's nothing there, right? That's probably what a lot of us think. So it should disappear. But answer me this, Miss Mattingly. What's 3 divided by 3? Okay. What's 3x to the 4th divided by 3x to the 4th? That's where it comes from. So it doesn't disappear. It's that this times 1 gives us this. And if I divide 3x to the 4th out of 3x to the 4th, I have 1. And it's actually dividing it out of negative 3x. Okay. 4x to the 4th. 4x cubed, 48x squared. Go ahead. Factor that by the greatest common factor. You know what? There's a little bit more I can do. Ms. Crabtree, what do they all share? A 4x squared, not just a 4x, a 4x squared. Very good. Pull that 4x squared out of all 3 of those terms. If you pull it out of the first term, what do you get? Ms. Abernathy? X squared. Ms. Arbogast, out of the negative 4x cubed.
Minus X.
Minus x, or minus 1x, or plus negative 1x. All right, Mr. Quinn, out of negative 48x squared. Well, 12 times 4x squared is positive 48x squared. So you're close, but not perfect. Negative 12 is very important to get the right signs. Okay, good. Let's keep going. 6x to the 5th, 9x to the 4th, 60x cubed. Stuff we can factor out of that? 3x cubed. Very good. Now, Ms. Birch, you're doing this really quickly. Do you have a special technique, or are you just kind of looking? Yeah, right? There are other ways to kind of figure out the greatest common factor. I could list all of the factors, but in the end, I think the most effective that we all should do is just kind of look and figure out. Mr. Bernberg, what's the first guy?
2x squared.
Mr. Black.
Negative 3.
Negative 3x.
Oh, minus 1.
This via more. What about the last one? I got 3x cubed and I got negative 6x cubed. Negative 20. Very good. Okay, good. All right. Next page. We're going to keep doing it. We're going all the way through all of them because this is always going to be step number 1 no matter how we factor. So whenever you guys are factoring, first step is do this. And either yes you can or no you can't. 4x squared and 49. Can I do anything? The 49 divided by 4, if you have a calculator you can try. 49 does not divide evenly by 4. 49 is not even, so you can't divide it by 2. Skip it. Number 2, x cubed minus 64. Skip it. 8x cubed, 27.
Yeah.
Nope. 5x to the 4th and 40.
Yeah.
Yes. 5x. Very good. You with me, Mr. Garcia? We're right here, the number 4. All the other ones we couldn't factor out a greatest common factor, but this one we can. 5x. What do I have left over, Mr. Sharipita? And what's your first number? First number. X cubed and 8. Very good. What about 9x to the 4th and 121? Did you try 3? 121 divided by 3? Well, you can try the number, but nope, 121 does not divided by 3. Does not divide by 3, okay? All right, so skip it. Next one.
We put CNF.
What?
We put CNF cannot factor.
No, we're not done yet. This is just step 1. We can factor these. We're going to factor these. This is just step 1. 128x cubed and 54. Good start, Mr. Stein. You know what? Sometimes if you don't know what the biggest number is, let's take an example like this. 48x and 96. You know, what's the biggest number? I don't know. Let's try 2. I know 2 divides into both of them, right? And this is 24. What's 2 into 96? 48. Okay, well, I factored out a 2, but look at what I have left over. Something that I could factor 2 out again. So, pull out another 2. 2 times 2. This is 12x. This is 24. Can I still factor out another 2? Okay, well, just pull out another 2. Could it be even more than 6? I get 6x plus 12. Oh my goodness, I can factor out a 6. 2 times 2 times 2 times 6, x plus 2. I could have actually pulled out a 48 from the get-go. A lot of people don't know that 96 is just 48 divided by 2. Okay, but this is... No, I'm saying, out of the first one. Okay, so just using this as an example. And showing you that maybe you don't see it, 48 goes evenly. You can just start pulling things out until you're done. What's 2 times 2 times 2 times 6? This is 4 times 2 is 8 times 6. What's 8 times 6? 48. 48 times x plus 2. That's what I got right here. Okay? So Mr. Stein says start with a 2. Great. If we don't see the biggest number, just start with something easy and then just keep going until you can't go anymore. You know, it's something that can be done. So we start with 2. What's 128 divided by 2? 64. And 54 is 27.
Yeah.
Can I divide these by 2, Mr. Stein? Can I divide 64 by 3? I know 3 goes into 27. Does 3 go into 64? No? All right, so stop here. I mean, we can't just assume just 2 and 3. We'd have to look at some other numbers, but actually there is no common factor here, so we're done. All right, let's keep going. 8n to the 4th plus 20n cubed minus 12n squared. I'll do this one. 4n squared. 2n squared plus 5n minus 3. Okay. Let's look at these. Nope. There's 4 things. Can't pull anything. There's 4 things. Nope. Nope. What about this one? 12x cubed, 3x squared, 24x, 6. Yep. What can I pull out? A 4? A 3. A 3 and an x, Mr. Clark? Just a 3. So I get 4x cubed, get x squared, minus 8x minus 2. Good. We have effectively done step 1 for every single problem.
Use the boxes for me.
We are going to be using the boxes in a second. Step 2. Back to the front.
Can you go back to number 10?
Which one?
Oh, the last one we were on.
Sure.
Oh, that was 11.
Yeah, it was 11. Step 2. Do we have an x squared plus bx plus c or an ax squared plus bx plus c? Okay? Well, there's going to be 2 things that we're going to do. We're going to start with this first, the ax squared plus bx plus c. Here's an ax squared plus bx plus c where it's just x squared plus bx plus c. A is 1. How do we factor? X squared minus 4x minus 12.
Whatever can multiply in the 12 and add 4.
We are looking for 2 numbers that multiply to get C and add to get B.
Oh, and this where you do like this thing?
Yes. Because we know x plus something times x plus something will have the form x squared plus this number times x plus this number times x plus the 2 numbers multiplied together. And since we know these 2 will add, that is why we come up with this number puzzle. What are the 2 numbers that add to get negative 4 and multiply to get negative 12. Everybody think about it and find it. Think about it. Find it. Make sure the signs are correct. And discuss with your neighbors. What do you got, Miss Abernathy? Negative 6 and positive 2. Because watch, if I distributed, it'd be x squared, 2x, negative 6x, and then negative 6 times 2, which is 12. This becomes 2 plus negative 6. That becomes negative 4x. This becomes negative 12. This is why we factor. So, let's keep looking. Sometimes, after we factor out, we're going to have an x squared plus a bx plus a c. Is this an x squared plus bx plus c? Close, but the a is different. We're going to go back to that. Close, we'll have to go back to this. Close, we'll go back to that one. Close, we'll go back to that one. Look at this one, bottom middle. Is this an x squared plus an x plus a c? Yeah. Yes. So this is what we're going to have to do. This is a multi-step process. Just because we factored out a greatest common factor does not mean we're done. We need to now factor this. And this is what we're going to be doing all unit, is we're going to factor to keep factoring. So factor x squared minus x minus 12. Go. You might have learned like a cross, and you put the numbers on the sides.
Yeah.
Okay, so if that sparks some memory. Okay, well, all I know is that if you remember, x plus something times x plus something will give you x squared plus something times x plus something. These two numbers add to get this, and these two numbers multiply. Add to negative 1, multiply to negative 12. Signs are very important. Okay, what are the two numbers that add to get negative 1 and multiply to get negative 12? Ms. Viamore, you got it? Not yet? Shh, Miss Birch, you're jumping out of turn here. Calling on random people. Mr. Stein, did you get it?
Oh. I was confused because I thought there was only one. I didn't. But now that you said something, maybe there is an answer.
No, I'm saying we look at this, what's left over, and I say that's an x squared plus a bx plus a c. Can you factor that? Yes. The answer is yes.
Yes.
Okay, Ms. Reyes, back to you. What are the two numbers that add to get negative 1? Okay, thank you. Just making sure you're paying attention. So this can be factored as x plus negative 4 and x plus 3. Now, all of a sudden, we started with this and turned it into that. That's pretty cool. That shows us there are 3 zeros. If I set this equation equal to 0, and we're going to be doing this in the future, what are the answers? Well, we know 4 would make this 0, making everything 0. We know negative 3 would make this 0, making everything 0. Is there any others? What could I plug into 4x squared to make everything 0? No? No? A 0! Oh my goodness, now we have an answer that's 0. Okay, let's keep going. Is this an ax squared plus bx plus c? Yes, but it's not an x equals 1. Let's keep going. I think we have exhausted all of our options. Okay, good. Yep. All right, we are going to come back to the ax squared plus bx plus c. Instead, we are going to look at our 4 items. We are going to factor 4 items by grouping. Now, I'm going to show you something that might change your mind about factoring. Ready? We're going to go to the last page. We want to factor x cubed plus 3x squared minus 4x minus 12. There's no greatest common factor I can take out of it. Watch this, okay? This is new to you guys. I think you'll like it. Go ahead and place all of the terms inside the boxes for me. Okay, so like x cubed, next to it 3x squared, minus 4x, minus 12. Okay, now we're going to play a little game. We are going to focus on columns and rows. Okay? Tell me, if I just showed you x cubed and negative 4x, what do they share? An x. Put the x right up there. That's what these share. Okay? Let's go with me now. Ms. Brown, if I show you 3x squared and negative 12, what is shared by those two that you can pull out? Can't pull out 4 out of this 3x squared. I can pull something out of this and this. It is just a number. 3. 12 divided by 3. You're already working on the answer, which was negative 4 if you divide negative 12 by 3. But I'm just saying 3 and 12, they share 3, right? All right, put that 3 right there. Now let's look at the row. X cubed and 3x squared. Ms. Chisholm, what does x cubed and 3x squared share? An x? Just one x? Yes, very good. Ms. Mattingly, negative 4x and negative 12. What do you think?
Negative 4.
Very good. Now, if you remember multiplication, if you watch the review video, I did a multiplication using this box method once. You remember that, Ms. Villamore? Did you like it? You used it on your test, right? Yeah. It works for some people. It's great. Well, what you do is you multiply your stuff together. Okay, what's x squared times x? X cubed, okay. What's x squared times 3? What is negative 4 times x? What is negative 4 times 3? You just factored this. Isn't that nice? Look at that. You just factored it. Yeah.
Do it on most problems?
Yes, we will be able to do it on most problems, but I'll show you how. If you only have 3 items, we're going to have to turn them into 4. And that involves a little bit of work on our part.
Why did you choose 4?
Because I didn't like it. I was biased. I was narrow-minded. And I decided to open up my mind. Try new things. Life lessons. And in the end, you guys will pick the way that you want to do it. You might do it this way and you enjoy it. Okay? All right, let's do this one. Go. And you know what? We're actually not done factoring that one on the left. Yikes.
So that's going to be 0.
What? We will eventually, but like to solve this, we'll find that we could actually factor this a little bit more. We'll get there. Okay, let's go. The one on the top right. Put your 4 items into the 4 boxes. Work rows and columns. Get it in such a way so that when you multiply your stuff together, it works. Now, there's a problem. X squared times 2 is positive 2x squared. You got a negative. 9 times 2 is positive 18. But x and 9, that's not positive 9x. This is the one, trick about this guy. Good. Help your friend.
What? Oh, is that right?
Nope.
No?
It's close. Okay, ready? I get an x, I get a 2, I get x squared, and I get a 9.
No. Why wouldn't you do negative 2 and negative 9?
I'm not done yet. Right? Because like 9 gets pulled out of 9x and 18, right? 2 gets pulled out of 2x squared and 18, right? Miss Reyes, do I have to take your phone? Miss Reyes, what am I going to tell you? No, you're not.
Yes, I am. Look, I did all the notes.
That's great. What am I going to tell you? Miss Reyes. Miss Reyes. Grab a calculator.
I have one in my backpack. Let's take it out.
That's what I'm going to tell you. There's no excuse to use your phone in my class, and you weren't using it to use a calculator. You think I'm stupid. I know how to change apps too.
I did not change that.
I know how to change apps. I'm really good at it. You know that double click on the bottom? It's really easy.
I don't have a better stick.
Oh, you swipe up. Congrats. X squared times x is x cubed. X times 9 is not negative 9x. X squared times 2 is not negative 2x squared. So what do I have to change, Miss Arbogast? Make this negative, make that negative. Okay, now it works. Negative 2 times negative 9. Okay, that still works. That's positive 18. That's my answer. X minus 2, x squared minus 9. Let's do this one. You have to think harder about the stuff that goes into it. Miss Abernathy, what did you put in that top right corner? Because I'm confused. I can't pull anything out of x cubed and negative 27. 1. If there's ever a situation where you can't get anything out, put a 1. Now, let's see. X cubed x to the 4th, x cubed 1, x cubed, negative 27, x, negative 27, x, negative 27, 1, negative 27. We got it. X plus 1, x cubed minus 27. Okay, we're going to skip the last one because we're running out of time. Go back to the beginning. What? Sorry, Mr. Stein, what happened?
You start with the one from the left and right answer, and you'll
No, it doesn't matter. Doesn't matter. As long as you're not multiplying like the corners and the corners together. Like it's the tops added together times the sides added together. Okay? All right. Now, if it's ax squared plus bx plus c, we are going to do the same number puzzle. But the two numbers need to multiply to get a times c. And the two numbers need to add to get b. This is what we've done before. Okay? So let's go back to the middle ones. Please go to the 10x squared plus the 13x minus the 3. There's no greatest common factor. It's an ax squared plus a bx plus a c. The a times c is negative 30. The b is 13. Find two numbers that multiply to get a times c and add to get b. Just go with me on this. Add to get b, multiply to get a times c. What are they? 15 and 2. You know, I was actually thinking 10 and 3 right away, but I would have been wrong. You guys are right. 15 and negative 2. Okay, ready? Ready? Let's create a box. That's a horrible line on the top. Create a box. Create your 4 things, just like you did. Okay, this is important. You got 10x squareds, keep them, 10x squareds. We did this the alternate way in the past. We will take 13x and rewrite it as 15x minus 2x. 15x goes here, or in one of the boxes, minus 2x goes in the other one. Doesn't matter which one, honestly. You can put these in any order. The minus 3 stays. Okay? So there's one extra step. If a is not 1, and we want to factor these 3 things, we make the 3 things look like 4 things. Okay? Please factor this now. This is literally how I taught you to factor the first time. It just ends up looking a little bit different. And I think you guys like it. I think I like it now, too. So 5x cannot be pulled out of 10 and 2. 2 can. Right? 10 and 2, 5? No. 2x. We got to make sure we pull the most out. 10 and 2, 2 and x. 15x and negative 3, 3. 10x squared and 15x, 5x, negative 2x and negative 3. Minus 1, very good. Now let's think. Do these all work out? 2x times 5x, 10x squared. 3 times 5x, 15. 2x negative 1, 3 negative 1, boom, you're done. You've just successfully factored this.
So all you did was multiply a times c.
A times c. It is necessary kind of in the reverse distribution of things. You got to work in this 2 times the negative 1 and the 3 times the 5. And the way to reverse that with your number puzzle is do a times c as the number to multiply to get to, and b still stays the number you need to add to get to. Okay? So here, 12 times negative 7. What is it? We need 2 numbers that multiply to get negative 84 and add to get 17. This is like the hard part. This is definitely the hard part. I'm thinking 84 divided by 12. Can you divide 84 by 12?
No, can I fix it?
That's 7. That's not it.
Can I tell you?
What is it?
Negative 21 times 4.
21 and 4. Nice. 21 and 4. So 21, it's got to be positive 1 and it's got to be negative 4.
Oh, well, yeah, either way.
Well, no. It's got to be this way. Don't say either way. 21 plus negative 4. That's the only way to get positive 17. Okay, so that was a tricky one. But let's do the part that used to be tough that now is nice and accessible. 12x squared, 21x, negative 4x, negative 7. You took the 21 and the negative 4. You rewrote this as 21x and negative 4x. Now factor. What do you think?
About this?
Yeah, the box.
I have absolutely no idea.
Do you kind of see, if you look at these two things, 4x, you can pull out of both of them? See that? Like what do 12x squared and negative 4x share?
4.
Right? 21 and 7. What do they share? 12x squared and 21x. That's a tricky one. What do they share? 3x. Negative 4x, negative 7. Negative 1?
Yeah.
Now let's double check. Negative 1 times 4x. Okay, that's good. Negative 1 times 7. Negative 7, that's good. 3x times 4x, 12x squared. 3x times 7, 21x. You know what we just did, Miss Harvey? We just factored this. This factored is 4x plus 7 times 3x minus 1. Factoring is undoing distribution. It's going to help us solve equations set equal to 0. Yes?
On the top right, put a negative 7.
I put a positive 7 because I put this as a negative 1, and that's necessary. Because I need this to be a positive 7 so that, did you put a negative? If you have a bunch of negative.
Negative 7 and a positive 1 originally, right?
But then do you have a negative 3x here?
No, I had a positive.
So 3x times 7 needs to be 21, positive 21x. Okay? Okay, so do we want to do another one, or are we ready to kind of move on? Like, let's look at this one in the bottom right corner. I already factored out a greatest common factor, but now what I look what I have. I have a 2x squared minus 3x minus 20. I can do my number puzzle, and I'm going to try to factor this middle part. Negative 60 and negative 3. It's got to be two numbers close to each other.
Common test, negative common test.
Huh?
Is it a negative 60?
Oh, it's 40. You're right. 2 times negative 20 is negative 40. Thinking this would be more. Okay, so let's think about 40. You think 10 and 4? That doesn't work. We think 8 and 5. That works. Which one's positive? Which one's negative?
How do we tell?
5 negative 8.
They have to add to get negative 3.
Oh,
Okay, so that's how we tell.
so it would be a negative 8.
Negative 8 and positive 5. Negative 8 times positive 5. Now, we will do 2x squared, negative 8x, positive 5x, negative 20 in our box. And I will quickly do this and then we'll move on. We get x, negative 4, 2x, 5. I'm checking. 2x times negative 4, okay. X times 5, okay. 5 times negative 4, good. So we already had the 3x squared, the 3x cubed out, but now we can turn this rest into 2x plus 5, x minus 4. This is an equation that you could solve without a calculator set equal to 0. It helps you find your imaginary solutions, your real solutions, all that good stuff. Okay? Let's please go to the next page where we'll learn some special factoring rules. Yeah. First, the difference of cubes. Please, somebody multiply x plus 2 times x minus 2. Everybody do that for me, actually, right now. Multiply x plus 2 by x minus 2 by distributing. Use your box if you want to. Don't use your box if you don't want to. Thank you. What'd you get, Ms. Viamore? That's right. Yeah, that's what I'm asking you. Which is? Yeah, what is that? Yeah, x squared minus 4. So what we find when we distribute is we have a positive 2x and we have a negative 2x. And these cancel and we end up with x squared minus 4. So look at that. I have something where it's like the same two things, they're just separated with a subtraction symbol versus an addition symbol, and it factors to be this. This, my friends, is the difference of squares rule. If I have a number squared minus another number squared that I want to factor, so it's like starting with x squared minus 4, what we are going to be doing is taking that x squared minus 4 and turning it into x plus 2 times x minus 2. Because we say x squared is x squared, 2 squared is 4. If I have an a squared minus a b squared, it is a plus b times a minus b. We'll do some easy ones, we'll do some hard ones. Let's start with an easy one. There aren't any easy ones, actually. I'll give you an easy one. Question number 5.5. X squared minus 36. Factor that. What you will do is you'll say, okay, x is being squared. 6 is being squared. This is a difference of squares. I can write a difference of squares as x plus 6 and x minus 6. We cool? Okay. Top left. What is squared to get 4x squared? 2x times 2x gives us 4x squared. What squared gives us 49, Mr. Clark? Okay. What is it, Mr. Reyes? I heard you. 7, thank you. Well, this factors as 2x plus 7, 2x minus 7. Is there something that could be squared to give us x cubed? Nope. Nope. X squared doesn't give us x cubed. Is there something that can be squared to give us 8x cubed? Nope. But 3x squared can be squared to give us 9x to the fourth. 11 squared can give us 121. This is 3x squared minus 11, 3x squared plus 11. That's number 5.
Wait, why is this double squared?
Well, it's x to the fourth, right? X squared times x squared is x to the fourth. So 3x squared times 3x squared is 9x to the fourth.
Oh, okay. I thought it was the square.
Okay. Let's see. Nope. I would do something else with this one. Okay. Let's look over here. Oh, look at that guy. What's that? X squared minus 4. Is that a difference of squares? Yep. What squared gives us x squared? X. What squared gives us 4? This turns into x plus 2, x minus 2 times x plus 3. Look at this guy. Oh, x squared minus 9. What's that? X plus 3, x minus 3. X squared is x squared. 3 squared is 9. This is a difference of squares. We will have to, in this unit, which is why it's so tricky, factor to be able to factor more. And all of these rules we'll have to learn and be able to use. Maybe if I factored this, it would turn into a difference of squares somewhere, you know? This is all the stuff that you have to think about. Last rule. Difference of cubes or sum of cubes? This is tougher to show you, so I'm just going to go with you, and it's going to always be up on the board. If you have an A being cubed minus a B cubed, or if you have an A cubed plus a B cubed, you have AB times, and this is something that, like, if we distributed, you'd be able to see, A squared, AB, B squared. We're going to talk about that in a second. It's the same with this one. A, B, A squared, AB, B squared. Now, we are going to use an acronym to help us remember what to do in between them. The acronym is SOAP. S stands for same, O stands for opposite, AP stands for always positive. That means if you have a minus sign here, use the same sign. Plus sign here, same sign. The next sign will be the opposite.
What are they saying for?
Just the value that is being cubed. Always positive. Always positive. Okay? Ready? Don't check your watch ever again, Mr. Bernerberg. I will throw that out the window as well. Cool kids with your smart watches.
They like every hour so you stand up or something like that.
Yeah, or when your friends text you too. Yeah, I know that too. X cubed is x cubed. What cubed is 64? 8 squared is 64, but that's good. 2 times 2 times 2 is 8. 4 times 4 is 16. 16 times 4 is 64. 4 cubed is 64. Okay, it's good to be excited about math. Ready? This is my A, this is my B. A, B. A squared, AB, B squared. Same, Opposite, always positive. If we distributed that, we'd get x cubed minus 64. We'll do one more. What cubed gives us 8x cubed? 2 and x times 2x times 2x is 8x cubed. What times itself gives us 27 if you multiply by itself 3 times? It's 3. 3 cubed is 27. Okay. A, B. A squared, A, B, B squared. Same, opposite, always positive. This ends up being 4x squared minus 6x plus 9. Thank you, most of you, for being attentive throughout the entire class period. You guys were